Right, we're going to take a look at symmetry. Now, take a look at this graph here. Can you see it's reflected, okay, over the x-axis? It is symmetrical around the x-axis. So this graph is said to be, it says it right here, symmetric with respect to the x-axis, okay? And have a look at this as well. Look at the xy coordinates. Can you see that the x has stayed the same as the y changes sign, okay? Now I'm going to actually go to this little thing here. So remember, this is x-axis symmetry. X has stayed the same, the y's changed sign. Here we go. X-axis symmetry. If replacing the y with a negative y produces an equivalent equation, then the graph is symmetric with respect to the x-axis. Okay, replace the y with a negative y and it stays the same. Symmetry around the x-axis. Let's have a look at y-axis symmetry. Here we go. Now clearly you can see that's y-axis symmetry, okay, reflected around the y-axis. Now this time, can you see that the y, okay, looks like it's staying the same as the x changes sign. Let's look at this one. So, y-axis symmetry. Remember, this is y-axis symmetry, visuals. So, if replacing x with negative x produces an equivalent equation, then the graph is symmetric with respect to the y-axis. And again, replace x with a negative x, an equivalent equation. Here, replace x with a negative x, the same y, okay? Then that is symmetric to the y-axis. We've got one more. Symmetry around the origin. Okay, now sometimes it can be hard to see. A classic origin symmetry is, if I can draw this, a nice circle. Okay, that's pretty symmetric, or whatever, around the origin. Actually, a circle, think about it, is symmetry around the x-axis, symmetry around the y-axis, and symmetry around the origin. So there's a good one of all three. Anyway, origin. So, symmetry around the origin. In other words, a point here, if I reflect it right through the origin, we'll go to there. A point here, reflected right through the origin, we'll go to there. Now, can you see, for this one, if you look at this here, both the x and the y, okay, are replaced with negative versions, and that is origin symmetry. Let's look at the statement again. So, if replacing x with negative x and y with negative y produces an equivalent equation, then the graph is symmetric with respect to the origin. Okay? One more look at that one. Okay? There we go. So, let's have a look at some examples. Okay, test symmetry. Now, visually, if you draw this, can you see that is symmetric around the y-axis? I mean, clearly you can see that. So, I know this is y-axis symmetry just by looking at it. Okay? But remember what it said. And what is y-axis symmetry again? Y-axis symmetry. If replacing x with negative x produces an equivalent equation, well, let's just have a look at it. Here we go. Here's the equation. Replace x with negative x. Okay, well, negative x squared will just produce x squared. Okay, negative times negative is a positive. In other words, we haven't changed anything. Okay, it's still the same equation. Okay, that's why it is symmetry with the x-axis. Sorry, the y-axis. Sorry. And that's like you see, again, visually. You can try replacing the y with a negative y, and you're not going to get symmetry there. Okay? It won't produce an equivalent equation. Again, if you want to have a look down this side part here, you go ahead and have a look at that. Okay? But I can see it's y-axis symmetry. I replace the x with negative x, and the equation stayed the same. Okay? Let's have a look at some other ones. Okay, right. How about this one? Well, let's have a look. Replace the x with negative x. Let's have a look at here. And you're not going to change anything. Okay? So remember, replace x with negative x. That'll just stay as x squared. Okay? You replace the y with negative y. Well, negative y to the fourth will stay at y to the fourth, because 4 negatives goes back to a positive. Okay? Still equals 5, of course. So there I replaced x and y with negative x and negative y. I had an equivalent equation. That's why this must be origin symmetry. But look at the graph. You can clearly see it's origin symmetry from the graph.